In today's episode, we'll try to classify text using a supervised learning model called Naive Bayes. We will try to predict whether a person is traveling to the United States or to Europe based on their travel plans. Here are some of the objects or places that they might be mentioning in their travel plans. We will take a look at 5 distinct travel plans representing 5 different people. Now, these travel plans might have some text, but they also might have some pictures of places or objects that these people want to see on their trip. Let's take a look at the first document. The first document will mention the US Capitol twice, and it will also mention fast food, hamburgers, once. Since this document mentioned Capitol twice and fast food, we will label it as USA. The second travel document mentioned the US Capitol once, but it mentions fast food, hamburgers, twice. Hence, we will label it as USA. The third document mentions hamburgers once. It also has a drawing of the USA map. But unfortunately, it mentions the Eiffel Tower once. And even though it mentions the Eiffel Tower once, we will still label it as USA because it had the USA map and fast food. The fourth document is different. It mentions the Arc from Paris twice. And it also mentions the Eiffel Tower once. This is why we can clearly label this as Europe. The fifth document has one mention of a USA fast food hamburger, but it mentions the Big Ben from London, and it also mentions the Arc from Paris. And because it has those 2 European elements, we will label this travel plan document as Europe. Our next step is to put that data into a data frame with 3 variables: the document number, the text, and the class. Our first document has 3 elements: the US Capitol twice and a burger, and that's why we label it as USA. The second document has the US Capitol and the burger listed twice, and that's why we can label it as USA again. The third document has the US Capitol, the USA map, and the Eiffel Tower. And even though it has the Eiffel Tower from Europe, we can still label it as USA because it has 2 objects from the USA. The fourth document has the Arc from Paris listed twice and the Eiffel Tower, and that's why we can label this as Europe. The fifth document has the Big Ben from London, a burger from the States, and the Arc from Paris. So 2 of those 3 objects are from Europe. That's how we can label it as Europe. But how would you label a unknown travel document? Just if they told you that it has 2 things: the USA map and the Eiffel Tower. To classify our unknown document, we will need to calculate 2 things from the Naive Bayes. We'll need the priors and conditionals. The priors are very intuitive. The probability of class equal USA is simply put 3 divided by 5. 3 travel documents were labeled as USA, and we had a total of 5 documents. Probability for class equals Europe is 2 divided by 5. 2 because we had 2 travel documents labeled as Europe, and 5 because we had 5 documents in total. For our unknown document, we'll need 2 sets of conditionals, one for the USA map and one for the Eiffel Tower. Let's take a look at the first conditional for the USA map. We're going to calculate the probability of a USA map given a USA class. Okay, the vertical line means given USA class. The first number here represents the count of maps in the USA class. The second number here is simply +1. We always do it, +1. In the denominator, the first number is the count of all the words in the USA class. And the second number is the vocabulary. What we mean by vocabulary is how many unique, distinct words do we have in all the classes. Our second conditional for the USA map will give us the probability of a USA map given a Europe class. As you remember, there were no instances in which the USA map occurred in the European class. That's why it's 0. We always add the 1. Then we divide it by 6 plus 6. 6. The first 6 is the count of all the words in the Japanese class. And the next 6 is the vocabulary, which is the distant count of all the words in all the classes. The conditionals for Eiffel Tower will be different, even though we will use the same formula. Remember, we had 1 Eiffel Tower in the USA class, and we had 1 Eiffel Tower in the European class. As you can see in the numerator, we always count 1 for both the US travel documents and for the Europe travel documents. Putting all the probabilities together, the prior for USA is 3/5, and the prior for Europe is 2/5. Switching over to conditionals, the conditional probability for USA map given USA class is 2/15. The USA map given the Europe class is 1/12. Now the Eiffel Tower. The Eiffel given the USA class is 2/15, and the Eiffel Tower given the Europe class is 2/12. Finally, we can calculate the combined probability for our unknown document 6. The probability of the document 6 being USA is 3/5, which is our prior, times 2/15, which is the conditional probability for a USA map being in a USA class, times 2/15, which is the conditional probability of a Eiffel Tower being in a USA class. And that equals to 0.01. And the same applies to the combined probability of the 6th document being a Europe. 2/5 is our European prior, times 1/12, which is the conditional probability of a USA map being in the Europe class, times 2/12, which is the conditional probability of an Eiffel Tower being in a Europe class. And that equals to 0.005. The class with the highest probability will win. So in this case, the USA class has a probability of 0.01, and the European probability has a value of 0.005. So the USA probability is higher. Hence, we can classify the 6th document as USA. The conclusion is that we can label the unknown document, which we call document number 6, as USA.